So this question is 7D double I. Now with 7D double I, it says find the area under the graph of this particular function from 0 to 100 and use the area of the inverse to help. So first what we've got to do is set up the integral. But in order to set up the integral, we've got to look at the original function. So the original function looks like this. And it has this shape and it passes through from 0 to 100. Now the thing is that if we try to find the integral of this, it's good to do it on the CAS. Very easy to do it on the CAS. However, the problem with this is that we don't actually exactly know how to find this with respect to t at this point, because finding the integral of logs, even though it has a formula, we don't really study it in methods just yet. So what we can do is we can, I guess you could say, rotate this shape. So if we rotate this shape, okay, so if you rotate it like this, so that it's, I guess you could say, the same sort of area. So this green area that I've shaded, it's going to be the same as this. Okay, so we imagine we're just rotating this and translating it. It's the same shape, just in a different section. So we've got to understand that there's a couple of things here that are going to be slightly different. This green equation is not the same as the top green equation. So this is actually the inverse. So if we look at the inverse, okay, and we calculate that, if we use our inverse formulas, so I'm not going to do it just yet, but if you do it, e to the power of t over 10 minus 1, okay, that's our inverse. We can then associate these values here with the same values that we've got here, except just obviously flipped around because it's the inverse. If this is 100, if we plug in 100 into here, we get 10 log E 101. So therefore, if we reflect it and find the inverse, this point here is going to be 10 log E 101, comma 100. All right, so that's our first step, that it's going to be now a change of bounds. Now the other thing we need to recognize is that when we find the inverse, okay, if I just draw another diagram here, okay, and I find the integral of this function, so if I find the integral of e to the power of t over 10 minus 1 dt, I'm finding this area here. Okay, so that small area down there is the integral of e to the power of t over 10 minus 1. But I don't want that area. I want this blue area here. I want this blue area that I've just highlighted here. But in order for me to find this blue area, I'm going to go area of the blue section, so area of blue, subtract the area of the pink. And when that, so when I say blue, I mean this is, I'm going to use the area of the whole blue. Okay, subtract the area of the pink, and hopefully that'll give me the area of the purple, as you can see here, the purple, so that should equal purple. So how do we write that as an expression? We write that as this square, so what was that? That was 10, the width was 10 log times log E 101. What was the height? It's the height of 100, isn't it? Okay, and then we're going to subtract the integral from 0 to 10 log E 101 of e to the power of 10 t over 10 minus 1 dt, and that's going to hopefully give us an answer. From here, what you'll find is that there are parts of it that you can evaluate by hand, and there are some parts that are not evaluable by hand. So let's just do this. So this is going to be 1000 log E 101 subtract e to the power of t over 10. That simplifies to, so 1 on k is k. So you find 1 on 10, but then you bring it out the front of the e, but it's going to be 1 on whatever you do it. So it's going to be 1 on 10, which means that we get 10 e to the power of t on 10. And then since negative one here is just by itself, it's y. But we're evaluating this from 0 to log e, 10 log e, 101. All right, now from this point, we're going to just evaluate our terminals, which gives us 1000 log e 101 minus 10e 10 log e 101 minus 10 log e 101. If we substitute 0 into there, then it gives us minus 10. Okay, but don't forget with these are all in part of a negative brackets. Oh, sorry, I forgot to include this over 10 bit here, over 10. Okay, from this point, if we evaluate this becomes, that crosses out, so this becomes 1000 log e 101 minus, I'm going to expand these brackets, that's going to be 10e log e 101 minus 10 log e 101 minus 10. So when we expand the brackets, it's going to be plus, and that's plus. And then from here, we're going to evaluate this section, and we've got e to the power of log e 101. So this becomes 10 times 101 for that section. And that becomes minus 1010. And then from here, we're going to add the 10, so that becomes negative 1000 for that side. And we're just going to tie in everything else now from here. We're going to bring those two things down. So actually, in fact, these two can be simplified together. We get 1010 log e 101 when you simplify those two pink things, minus 1000. And that should be your area for that particular integral. Now, I do recognize that the question here does have something slightly different with the 1000. However, I'm pretty confident that it should be 1010 on the front.